In section 2.2, we're going to continue solving equations. The equations are going to get a little bit more complex, and you're going to have to do multiple things to try and isolate the variable. Let's start with problem number 14. We're going to end up having to use the addition properties of equality and the multiplication properties of equality repeatedly to solve these types of equations. In all these equations, kind of keep your eye on the ball. Our goal is to solve for the variable. Now in this case, what kind of things are happening to the variable that it's not by itself? Well, it's being multiplied by -7, and you're also adding 4 to this. We need to undo these things. You want to undo them in the opposite order of your order of operations. So parentheses, exponents, multiplication and division, addition and subtraction. So let's start here. Let's undo the addition and subtraction first. So in this case, it would be to do what? Subtract 4. All right, so I get -7y equals 56. Next, you do multiplication or division. And these are rough guidelines. You can change things up as needed. What's next? Divide by -7. So divide both sides by -7. 56 over -7. Y is what? -8. Good. How would I double check it if I wasn't sure? Yeah. Plug in -8 for y. -7 times -8 is positive 56. 56 plus 4 is 60. It checks. You can check all your answers on these types of problems as you go through your work. Let's try some more here. Why don't you try one? Problem number 16. -4p plus 3 equals 43. After you get the right answer, or what you think is the right answer, go back and check it. Try not to rely on your calculators as you go through these problems in the first chapter. As with the last one, subtract 3 to get started, because we want to try and get this by itself. We're going to do the addition and subtraction first. -4p equals 40. To undo a multiplication, we'll use division. So I'll divide both sides by -4. P equals -10. Like the previous one, that's going to check. -4 times -10 is a positive 40. Positive 40 and 3 gives me 43. So far, so good on the first two. All right, well, let me wake you up a little bit more then with problem number 18. 2/5 of C minus 12 equals 2. A little bit more challenging on this one. What do you suppose we should do to start this one? Add the 12. All right, add the 12. That's a good way. All right, so let's add the 12. And I get 2/5 of C equals 14. Okay. Yeah, so there's a couple ways to do this, but we've got a fraction in front of that constant, or excuse me, a fraction in front of our variable. So there was a way we did this the other day. Do you remember what we did to get rid of that coefficient? Perfect. Multiply by the reciprocal. What's the reciprocal of 2/5? 5/2 times by 5/2. So if I multiply both sides by 5/2, do I have to really think much on the left-hand side? No. That's all going to cancel out and leave me with a 1 times C. Now on the right-hand side, let me write that as 14 over 1 times 5 over 2. Yes. Let's do some cancellation. 2 goes into 14 7 times, and 2 goes into 2 once. What are we left with? 35. Now that's one way. And it's really good, especially if you're comfortable with fractions here. I mean, multiplying by the reciprocal. Let's look at this a different way. And it's up to you what you're most comfortable with. Some people just aren't a fan of fractions at all. And a lot of times, depending on the problem, I'll recommend that you just get rid of the fractions right away. So let's look back here at 2/5 C minus 12 equals 2. If you're one of those that thinks fractions are a 4-letter word, then maybe you want to get rid of them to start with. So what I'll do is I'm going to multiply both sides of this by the lowest common denominator. Now, there's really only one denominator, right? The rest of these have common denominator 1. So the lowest common denominator is just the 5. So I'll multiply the left-hand side by 5 and the right-hand side by 5. But notice I put parentheses around this. What do I have to do with that 5 in these parentheses? Yeah, times, distribute. So basically that 5 is going to multiply everything. 5 times this term, 5 times this term, 5 times this term. The bottom line is that each one of these terms gets multiplied by 5. Now I'm not going to write 5 over 1 and 2 over 1. 5 times 2 is just 10. 5 times 12 is 60. But here's where we can make a little headway. What happens when I multiply 5 times 2/5? Yeah, I'd suggest that before we do the multiplication, we just do a little cancellation first. Make our life a little bit easier. So that leaves me with 2C minus 60. Are you comfortable with that there? On that cancellation? It seems like it bothers you a little bit. So for my convenience, I wrote that as over 1, and I just did that cancellation there. So that leaves me with 1 times 2 over 1 times 1, 2 over 1. Just 2. To finish this up, I'll add 60 to both sides. I get 2C equals 70. What do I have to do to finish now? Divide by 2. And 70 divided by 2 is 35. If you're more comfortable just getting rid of the fraction, the denominator right away, that's great. This way works pretty good too. The first one? It is. What you have to be careful of is sometimes people want to multiply by 5/2, and they'll multiply by 5/2 here and here, but forget to do it there. So got to be a little bit careful with that one. But let's do some more examples. I want you to be comfortable solving these things. We'll come back and do some more that deal with fractions. But for now, let me continue with problem number 24. I've kind of written over my book. Is that a 6.6 minus 4 or equals 4.1 minus? 0.6. All right, thanks. 0.6 equals 4.1 minus x. Okay, well, let's see here. Our variable's on the right-hand side. It's right here. So, there's a couple ways you can do this one. And I'm not going to go over all of them. What do you see? What would you do? What would you do first? All right, let's get the 4.1 on the other side. So that means adding the opposite or subtracting. Subtract 4.1. So on the left-hand side, what am I left with?
X.
Negative x. Good. Keep in mind that the sign doesn't change just because we subtracted away the 4.1. So on the right-hand side, we're left with negative x. On the left-hand side, we're left with negative 3.5. Are we done?
No.
No. Why not? What else do we have to do? Yeah. We got to make that a positive x, so you can divide or multiply by negative 1. Most people seem to think of this as a division, so I'll follow suit. If you divide both sides by negative 1, we get x equals 3.5. Nice. You can check it. 4.1 minus 3.5 is 0.6. Now, some of your problems are going to go a little bit beyond what we have here, and you have to deal with what are called grouping symbols, parentheses for most of us. Problems like number 26. Yes, please.
For 24, why did we divide by -1? Why we didn't divide by -3.5?
Well, if you divide by negative 3.5, that would put it over here. So, for instance, if I divide this by negative 3.5, then I have to divide that by negative 3.5. This over this would give me a 1. This over this would give me x over 3.5. So it doesn't finish solving the problem. We did get rid of the negative, but you still have to get x by itself. Okay. Yeah, no, I appreciate the question. 2 times negative 3a plus 2 plus a equals 2. So what's different about this one is you've got these grouping symbols first that you have to deal with. By that I mean the parentheses. How do you think we're going to deal with the parentheses? What should we do? Distribute. Good. So that 2 is going to multiply itself by both of those terms. Andrew, can you distribute that for me? What would I get, please? Good. Thank you, sir. Negative 6a plus 4 plus a equals 2. Now let's combine like terms here. What are the like terms? We went over that the other day.
6 and 8.
There you go. So negative 6a and a. Now it's not really written here, but what's understood to be here as far as the number of a's? It's understood to be a 1a there. So when I combine the like terms, how many a's do I have? Negative 5. Negative 6 plus 1 is negative 5. Let's rewrite that. Negative 5a plus 4 equals 2. Making some progress. Mark, what next? Thank you, sir. Subtract 4, negative 5a equals negative 2. Last step, someone else. Yes? Excellent. I like that. Especially that you said divide it on both sides. Well done. So, what happens when I divide negative 2 by negative 5? What do I get? Positive. Yeah. 2/5. Pretty nice. Pretty nice. How are we looking on problem 26? Okay. Yeah, Andrew? Correct. So what's happening here, if we take kind of a closer look at this, let's write it as negative 6a plus 1a plus 4. So all I did is I changed the order in which I added things. Now, a is common to both of these things. So I can kind of undistribute. I can factor out the a. So let me do that. Negative 6 plus 1 times a. These two things are essentially the same. If you distribute, you get negative 6a plus 1a. So these two things are the same. Now let's combine what's in here. Negative 6 plus 1 is 5 times a, or negative 5 times a. So there's no square involved. So it's a good question, but I hope this is pretty convincing that there's no squaring involved. Good on that? Okay, yes, sir. Exactly. So where you would get the squaring is if you would have negative 6a times 1a, and then negative 6 times 1 would be negative 6, a times a would be a squared. So yeah, that's where you would get the squaring, as if it was a multiplication problem. All right? So yeah, thanks for that. Yes. Your turn for one, problem number 28. 16y minus 8 times 3y minus 2 equals negative 24. Let me give you a suggestion in this one. When you get rid of the grouping symbols, what you should be distributing to this is distribute the negative and the 8. So distribute that to both of these. Now if you get past that one, let me give you another one to try. I'm going to walk around, see how you guys are doing. Help each other out though. Turn to somebody else, engage in some genuine human discourse, and work with each other. So problem number 32 would be 100f minus 75 equals 50f plus 75. And that one does actually work out to be pretty nice. Both of these work out to be nice integer numbers. So like I said, I'll walk around and try and help out. But please help me by helping each other as well. Okay, so for the first one, let's distribute the negative 8. I get negative 24y plus 24 equals negative 24. How about 16 here? Sorry. All right, there's too many 24s there. Okay, before I do anything else, I'm going to combine like terms on the left-hand side. What's 16 minus 24? Negative 8 plus 16 equals negative 24. This is kind of like the problems we started out with this section doing. I'm going to get rid of the 16 here by adding negative 16. You could also think of it as subtracting 16. For me, it's convenient to think of it as adding negative 16 because on the right-hand side, I'm adding two numbers that have the same sign. What's the trick for adding two numbers that have the same sign?
Keep the sign.
Yeah, add the numbers, keep the sign. Last but not least, divide both sides by negative 8. 40 divided by negative 40 divided by negative 8 gives me a y equals 5. How many people got that one? Yay, give yourself a little round of applause. Good job. All right. Problem number 32. This one's a little bit different in as much as we got the variable on two different sides. We need to start out by getting the variable on one side. Let me make a suggestion that you always put the variable on the side with the bigger coefficient. Since 100 is bigger than 50, let's put the variable on the left-hand side. So I'm going to subtract 50f from both sides. So, okay, 50f minus 75 equals 75. Great. Just great. Now, I've got my variable on one side. I want to put the constants on the other side. So I'm going to add 75 to both sides. 50f equals 150. What's the last step? Divide by 50. 50 is multiplying f. To undo multiplication, we'll use division. F equals 3. Beautiful. Okay. Anything else on 32? We okay with that one? Let's try problem number 92. Kind of a little step up. Problem number 92 looks like this. 2 minus parentheses 4x plus 7 is equal to 3 plus 2 times the quantity x plus 2. Now I can tell you why I chose this problem to work on. It's because we got a negative here that separates these things. And I want to make sure that we're clear with what to do in such a circumstance. The 2 doesn't multiply this. I'm not going to distribute this. If anything gets distributed, what would it be? Negative 1. So we'll kind of put that in there just, for our own benefit. We're going to distribute the negative 1 there. So the 2 stays out in front. What does it look like if I distribute the negative 1?
It's gonna be same with change the sign.
All right, nice. It's going to change the signs here. So minus 4x minus 7 equals 3 plus 2x plus 4. After you get rid of the grouping symbols, if there's any like terms, combine the like terms. So on the left-hand side, we can combine like terms. 2 minus 7 is negative 5. On the right-hand side, I get 2x plus 7. Now, just a minute ago, I gave a suggestion as to what side you should put the variable on. the left-hand side or the right-hand side, and it was based on the size of the coefficients. Where should I put the variable? On the left-hand side or the right-hand side? All right, so on the side with the 2x. So on the right-hand side. Because 2 is bigger than negative 4. The reason for this is because it's going to help you avoid mistakes later on down the line. There's really two possible mistakes you can get by doing it the other way. You can get it right moving things to the left-hand side, but I think it's a little bit safer to move things to the right-hand side in this case. What equation do I get from this? Thanks, Sam. Negative 5 equals 6x plus 7. You've got the variable on the right-hand side, so let's put the constants on the left-hand side. What does x equal? Negative 2. So divide both sides by 6. Negative 2 for x. How could I check it? Yeah, I could plug it back into the original equation. Put it all the way in back up here and see that it works. And actually, it's not too bad. Because if I plug in a negative 2 for x, what's negative 2 plus 2? 0. And 0 times 2 is 0. So the right-hand side would be a 3. If I plug in negative 2 here, I get negative 8 plus 7 is negative 1. Negative 1 times negative 1 is positive 1. Plus 2 is 3. I should probably have written that out. My bad. But you can check these things, even though sometimes they might be a little bit longer. Let me go back and look at things from right here. And just show you, give you a little bit of heads up as to why I suggest, and it's only a suggestion, that you move things to the right-hand side. Negative 4x minus 5 equals 2x plus 7. There's nothing mathematically wrong with moving things to the left-hand side. But people are going to make more mistakes with the negative numbers than they will with the positive numbers. So hopefully you're going to get negative 6 minus 5 equals 7. So negative 6x minus 5 equals 7. Great. Then add 5 to both sides. Negative 6x equals 12. And if you get this okay, you'll probably be all right. But later on, when we start dealing with linear inequalities, if this was a greater than sign or a less than sign, when you divide by negative 6 here at the end to finish things up, it's going to give you one more chance for a mistake because you're going to have to remember to reverse the sign of the inequality, reverse the direction. Now, you don't have to do that with an equal sign, but you will with a less than sign or a greater than sign. So it really gives you a couple chances to make a mistake. But look, there's nothing wrong with it. If you're comfortable doing it that way, go ahead. Yes?
So what if in the exam I get it kind of differently?
Oh, there's a lot of different ways you can do these types of problems. I will look through at your work.
The way I know how to do it is moving numbers and change the signs. That's how I do it.
I mean, that's kind of what I think we did here. I mean, I'm
Yeah,
not sure.
but I don't like do the minus 4, minus 2x. So actually I just move the numbers. To
So
the
you
other
just
side.
move it to the other side?
Yeah, and get the
Yeah.
x's on
Because
the
when
other
something,
side.
I mean, that's really what we're doing is we moved it to the other side.
Oh, okay.
By putting the 4x here, I'm really moving it to the side, and then I combined it right away. So we essentially we're doing the same thing. All right. Anything else on 92 here? Normally, what I suggest is you move to the side with the larger coefficient. So in this case, we had coefficients of 2x and negative 4x. So since 2 is bigger than negative 4, that's why I suggested that we move things to the right-hand side. What that does is it avoids us having to use negative numbers as much. All right? And later on, for other problems, it'll help us avoid a different mistake. So there's a couple of advantages. But look, Andrew, if you, for whatever reason, move things to the left-hand side, you could still get the problem right. All right? There's nothing really wrong with doing it that way. Yeah, and that's fine. That's fine. I tend not to demand people do it my way. I don't know. Have you ever had math teachers that say, "Gotta do it this way"? Yeah. All right. So some of you have, some of you haven't. I'm not that way. I make suggestions. I show you some insights, and it's up to you to find what works. I will look at your work, and I'll grade it carefully. I'll give you partial credit if you make a small mistake, etc., but I need to see your work. Back up to problem number 42. Now, I'm not sure whose idea it was, bless you, to put 5s and S's in the same problem, but I'm trying to do my best to make sure that you can see the difference between both of these. Here's a 5, that's an S, etc. What about this problem is a little bit more challenging than some of our other ones? It's got the division, the fraction. So to make it a little bit easier to deal with, at least at the start, how about if we try and get rid of the fraction? What could I do to get rid of the fraction right at the start? It's a great suggestion, but let me be careful about something. 40 minus 8s, because you're subtracting or adding those things, you have to regard it as one term. These things are mathematically married, and if you cancel into that marriage, if you break up that marriage, I'm going to write homewrecker on your test. Don't want to be a homewrecker, all right? We can't cancel into that. So yeah, I know it's tempting. It's like, ooh, look at it. It goes in there 8 times. You're right, but we can't do that. So I think I heard another suggestion that we can multiply both sides by the lowest common denominator, 5. So I'm going to multiply both sides by 5. The left-hand side by 5 and the right-hand side by 5. Now, how's that going to play out? On the right-hand side, we're going to distribute negative 10s plus 40. Yeah. On the left-hand side, remember, we're multiplying by 5 so that we can get rid of that denominator. So on the left-hand side, look, the 5 cancels itself out. And you're left with 40 minus 8s. Ooh. Now here's a good question for you. Which side has a bigger coefficient, the left-hand side or the right-hand side? The left-hand side. Negative 8 is bigger than negative 10. So what I'll do is I'll add 10s to both sides. I should end up with a nice positive coefficient for my variable on the left-hand side. Okay, so on the right-hand side, that cancels. I'm left with 40, 40. What do I get here? Yep, thank you, ladies. 2s. Let's keep going. I've got my variable on one side. Sabrina, what else should I do next? Subtract 40. Question?
Oh, no, I was going to say let's keep S by itself and take off the 2. And
All right.
make the division 40 and 40 the other side.
All right. Well, that would work, but I think this problem is a little bit easier right here, since we just have 2s equals 0. What should I do to finish this one? Divide by 2. What does s equal? 0. Wow. All that work for nothing. All right. But 0 is the solution. So if you go all the way back here, 8 times 0 is 0. End up with 40 divided by 5, that's 8. 2 times 0 is 0, plus 8 is 8. So you get 8 on both sides when you check your answer. Bottom line is that it works. Yes?
I kept that 40 and the minus 8s inside parentheses and put a division sign, 5, that would be the same as the fraction, right? If I just multiply both sides by 5 the same way, right?
It sounded right. I'm not sure I quite followed everything, but so you got 40 over 40 minus 8s over 5, and what do you want to do with that part now?
I wanted to keep the 40 minus 8s in parentheses and put a division of 5.
Oh, all right. So 40 minus 8s divided by 5?
Yeah.
Yeah, you could. And then do what from there?
And then I would still multiply both sides by 5, but that would be the same thing, right?
Yeah. These two, it's just a different way to write the same thing. Yeah. And if that works for you, go for it. We're going to do a few more with fractions. We're going to spend actually a fair amount more time with fractions. And I'm really hoping that you're going to get comfortable working with these fractions. We've done a fair amount so far, and we're going to continue to do some more. Next up, let's try, I'm debating here. Let's try 58. Three-eighths times 14 minus u equals negative 3u plus 6. All right, so some more fractions. There's a couple ways you could work this one. I'd suggest we start by getting rid of the denominator first, or getting rid of the fraction altogether. Let's not leave it to the same couple voices to do all the work, though. Somebody new. What could we do to clean this problem up a little bit and make it a little easier to solve? Yeah. Nice. I like that. Let's multiply 8 on both sides. And what that's going to do is it's going to kill off this denominator here, and then we won't have any more fractions to deal with. So 3/8. So I'm going to multiply both sides by 8. So let's do that this way. So 8 here and 8 here. Now on the left-hand side, when I multiply by 8, let me just do this. On the left-hand side, when I multiply by 8, is it helpful to write it as 8 over 1? Yes. Why am I multiplying by 8? Yeah, so you can get rid of the fractions, right? So what you want to do here is cancel the 8's, and we're left with 3 times 14 minus u. On the right-hand side, there's no cancellation, so I can just distribute if I want. That's negative 24u plus 48. On the left-hand side, I continue to distribute. 42 minus 3u equals negative 24u plus 48. But that's the tough part, is getting rid of those fractions. Nick, what should I do next? We could. My preference is to figure out where I'm going to put the variables first, but you can subtract 42 from both sides. Nothing wrong with that. Let's decide where we're going to put the variables. On the left-hand side, sure. Negative 3 is bigger than negative 24. So, how do I get this over to here? Add 24 to both sides. Add 24u to both sides. Dino, what equation would I get? (42). What's negative 3 plus 24? 21. So 21u equals 48. Now, just a minute ago, Nick suggested that we move the 42 to the right-hand side by subtracting it. Let's do that here. Since we got a variable here, I want to put the constants over here. So 21u equals 6. What does u equal? 6 over 21. Now, hopefully, you're going to take the time to reduce that and put that in lowest terms. What would that be in lowest terms? 2/7. Wow, a lot of work on that one. Let's do a couple more. Are there any thoughts or questions on that before we look at problem number 68? Okay, problem 68 it is. So here you have an equation that has basically two fractions, two rational expressions equal to each other. My preference to start this one is just to distribute the numerators. So 10a minus 14 over 4 equals 9a minus 9 over 3. And actually there's other things we could have done on this one as well. But let's just look at it from here. So these terms are stuck together. I don't want to cancel the 4 and the 10 or cancel out the 2 from the 14 and the 4. Likewise, I don't want to cancel the 3 into the 9, etc. Let's just get rid of the denominators altogether here. So, Megan, what's the lowest common denominator between 4 and 3? 12. So let's multiply both sides by 12. So Lakendra, is there any simplification I can make between these two? All right, so 4 goes into 4 once and into 12 3 times. Good. How about on the right-hand side? Three into 12 goes 4 times. Cool. So a little bit of symmetry there of sorts. Thank you. I'm left with 3 times this parentheses equals this parentheses times 4. The nice thing is I got rid of the denominators. All done. So let's distribute here. 30a minus 42 equals 36a minus 36. The big step, though, was right here. Getting rid of the denominators. Right here. Let me pause for a second. Are you okay with what we did to get rid of the denominators? Because that's going to be your biggest challenge. I know you all. You like fractions like eating lima beans or broccoli for most of you. It's just not your favorite. So you want to get rid of those fractions right away and make it a user-friendly problem. What side should I put my variables on? The left-hand side or the right-hand side? The right-hand side. 36 is bigger than 30. So I'll subtract 30a from both sides. Once I get my variable on one side, I can put the constants on the other side. So that's the part without the variable. Add 36 to both sides. And you get negative 6 equals 6a. Almost done. Last step is to divide both sides by by positive 6, I should say. What do I get for a? Negative 1. Wow. Pull out the oxygen bottle, man. That was a long one, right? Whew. You can check it. Let me actually show you a check on one of these. So I'm going to plug in negative 1 as my solution. So negative 1 here and negative 1 here. On the left-hand side, to simplify this, what do I have to do in the parentheses first? This is your order of operations stuff. Yeah, I hope that's like second nature, right? Parentheses, exponents, multiplication, division. So 5 times negative 1 is negative 5 minus 7 over 4. Over here I get 9 times negative 1 minus 1 is negative 2. To continue, negative 5 minus 7 is negative 12. I should probably put a question mark here because I don't know that they're equal yet. Negative 24 over 4 is negative 6, and negative 18 over 3 is also negative 6. So, wow, a lot of work, but eventually it did check. Let me give you one to try. Problem number, I'll give you a choice, 86 or 90. 2/5 x plus 1 equals 1/3 x, or 1/3 plus x. 1/3 plus x. Clean that up in a second. So that's 86. 90 looks like this. 1/3 times 7 minus 7x equals negative 21. So I think I heard somebody want 90, but I'll pick your favorite one. Try and do both. I'll walk around and try and help out. See what you can come up with. because this is a proportion. This is a proportion, so you can do that. Effectively, what you're doing is you're doing kind of what we did here. When we multiplied both sides by the lowest common denominator, look at what we got. We got exactly what you did down here. You distributed the 3 times this, and then the 4 times this. That's exactly what we got. So you're not doing anything really much different than what we did.
Over here, is it like still right? I did something wrong. I did something wrong over here.
Well, because you made that, I don't know, somehow you got a 4a here. I don't think there should be a 4a. It should be like,
Because the 4 went through the 9.
but it's 4 times 9 is 36.
Oh,
I think you regarded that as an a. So I think you misread you right in there. So I'll give you a heads up. Problem number 86 works out as a fraction. So if you get a fraction, that's a good thing, because that's what the right answer is going to have in it. In working problem number 86, if you're multiplying everything through by the lowest common denominator, the LCD is 15. Each of those terms, the 2/5 x, the 1, the 1/3, and the x, every one of those terms gets multiplied by that LCD. You can't just pick and choose like, oh, I'll multiply 2/5 by 15 because that'll get rid of the denominator. Everything gets multiplied by the LCD. Whether or not it has a denominator doesn't matter. This gets multiplied by 15. This gets multiplied by 15. Everything is multiplied by 15. No, because in putting parentheses around this, it really move one up into the numerator and put a denominator 5. So that makes it effectively 1/5, or multiply by 2, it's 2/5. There, it's just a 1. So you can't make that change. What you have to do is you have to multiply every term by the 15. Let me do that up here. So problem 86, everything. This gets multiplied by 15. 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 Everything gets multiplied by 15. You can't just kind of pick and choose like, oh, I'll multiply this by 15 and then this by 15. Everything has to be multiplied by 15. Really, you're only cancel Okay. So with this first one, I'm going to take and multiply both sides by 15.
You call Serena.
Oh, thanks. All right, so 2/5 x. Like I said, both sides get multiplied by 15. So left-hand side by 15, right-hand side by 15. Now that 15 has to distribute itself to both of these terms. I can't just cancel the 5 into the 15 here and the 3 into 15 here. I've got to distribute before I do anything like that. So the bottom line, and what I said just a couple minutes ago, is that everything gets multiplied by 15. Now with the terms that involve fractions, it's probably not a bad idea to write that as 15 over 1. All right, let's do some cancellation. 5 goes into 15 how many times? 3. 3 times 2 times x, 6x. Good. Plus, do I need a calculator for this one? No. 15. Good. Five. 5 times 1 over 5 is just 5 plus 15x. So great. In one step, we got rid of all the fractions. Now, I saw a lot of different varieties of things here. Is there something else that I didn't get a chance to help you with, you're a little unsure about? This is probably the best way I would suggest that you do this. What side should I put my variables on? The right-hand side. So subtract 6x from both sides. 15 equals 5 plus 9x. Subtract 5 from both sides. And last but not least, divide by 9. If I divide by 9 on both sides, then the right-hand side is going to cancel. I'm just left with x is 10/9. Yay. You could check it. It's a lot of work to check something like that, but you could check it. We'll just assume I'm right. Always a good assumption, right? Nod yes. Yes is the correct answer on that one. Problem number 90. 1/3 of this. Well, that 1/3 is kind of a pain here. 7 minus 7x equals negative 21. So just like the last one, I'm going to start by getting rid of the fractions. I'm going to multiply this side by something and this side by something. What something should I multiply by? 3. Now on the left-hand side, there's really nothing to distribute. I don't distribute it when I'm multiplying. I don't distribute this times this and then this times this. I just multiply once. The 3's cancel. I'm left with 7 minus 7x equals negative 63. Variables on one side already, so put the constants on the other side. Negative 7x equals negative 70. And when I divide by negative 7 on both sides, what do I end up with? Positive 10. Whew. All right. Have you had enough of fractions for a while? Want to take a break from fractions? Okay, cool. So we'll do some decimals then. All right. Some grimaces like, that's not really much of a break. Let's do one problem involving decimals, and then we'll call it a day on this section. And let's see which one I want to do. Let's see. There's a couple. There's 82 and let's see, where's 38? Let's try 82. Is something wrong with 82?
No, I looked at it and I'm like, I bet he's gonna pick that one.
All right, tell you what, we can do 88. All right, we'll do 88. Long distance dedication to a lonely heart in the upper left-hand corner of your math class. Problem number 88. So 0.105x plus 0.06 times 20,000 minus x equals 1740. Okay,
I have a question.
go ahead.
It's actually about the other problem. I didn't get 10. I got 4. And I checked it and I don't know, like I can't get 10. I don't understand how you got 10.
Well, I'll tell you what. Let's do this. Let's check 10. Okay, does that work? So 1/3 of 7 minus 7 times 10 would be 70, right? So 7 minus 70 is negative 63. 1/3 of negative 63, 3 goes in there, negative 21 times. So it checks. If you want to come show me after class or something like that what you did, we'll go through and we'll find your mistake. All right? A couple of different ways we could work this one. But the one thing that's troubling is you've got all these decimals. Now before I work on this one, let me show you something about multiplication. If I have, say, 100 times 6 times 7, you tell me which way is correct to multiply this out. Is it A, say, oh, that's 600 times 700, which is 420,000? Or is it B to say, oh, well, that's 600 times 7, which is 4,200? B, right? This one. So when you're multiplying, when you have three things that are multiplied, what you don't do, and what I did up here, is you don't distribute. You only distribute if there's a parenthesis and an addition or something like that. That's when you distribute. Same is going to be true here. And I'm as anxious to get done with this section as you are, so we're going to try and be a little bit short with this one. The problem that we have here is that we don't like all these decimals. I need to get rid of them. So I'm going to multiply by something to get rid of the decimals. Question is, what do I multiply by? Well, I could multiply by 100, and that would move the decimal 2 places to the right here. But if I want to get rid of all the decimals, I need to move this 3 places to the right. So I'm going to multiply by 1,000, and 1,000, and 1,000. So all 3 of these things get multiplied by 1,000 to help clear out the decimals. What does that give me here? 105x plus. Well, let's move this decimal 1, 2, 3 places to the right. 60. 60 times 20,000 minus x. Now notice what I did not do. I did not distribute this 1,000 to what's inside here. Last but not least, if I multiply this by 1,000, I'm just going to add 3 zeros. So again, moving the decimal 3 places to the right. Okay. Let's see what we can do with this one then. What should I do next? Distribute the 60. 6 times 2 is 12. How many zeros should I write after that 12? 5. Oops, there's also a minus 60x. Thank you. I forgot to do the distributing part. There's like terms that I can combine. 105 minus 60 is 45x plus 1.2 million equals 1,740,000.
Minus 60x.
Did I forget the minus 60x?
No.
Good, why not? Someone else tell me.
Because it's the 45.
Yeah, I combined these two. Good. But I appreciate you checking me, though. Let's subtract the 1.2 million from both sides. So 45x equals, what, 340,000? No, 540,000. 540,000. Okay, so x equals 540,000 divided by 45. Boy, I just feel really undermotivated on this one. Let's see. 620, 1, 2, 12. How many zeros? 120. No, it can't be 100. 12,000? Oh, feeling. I know, but I'm not letting you guys use. I wouldn't give you one that the numbers worked out. Yeah. All right, I feel guilty. If no, let me change it. If I had a conscience, I'd feel guilty. I'm just gonna do this one on the calculator. Yeah, 12,000. That's what I said. Yay. Yay, good on me. 12,000. I will give you friendlier numbers than this. Absolutely. But what should you get out of this? What are the important aspects of this problem that you should realize? Getting rid of the decimals. And you're going to multiply by a 1 followed by as many zeros as you need to move the decimal. I needed to move the decimal 3 places, so I multiply by 1,000. If I needed to move the decimal 2 places, I could get away with multiplying by 100. But you have to choose one number for everything. In this case, we chose 1,000.
Excuse me.
Yes.
Can you repeat from the third steps, please?
The third step, I mean moving down. So after we distributed, we had like terms. The 105x and the minus 60x. So you can combine those. 105 minus 60 gave me the 45. My variable's on the left-hand side. So I subtracted the 1.2 million from both sides to try and get the variable by itself. The last step, since I got 45x equals 540,000, I'm going to divide both sides by 45. When I do that, this simplifies as 12,000. For homework, section 2.2. Try 11 through 35, 47 through 91, 111, and 117. It starts on page 120. Whew.